What are things that affect the time of a projectile flight? Well, those are going to be the vertical motion variables, which are v, y initial, your acceleration due to gravity, and the initial height that you launch your projectile from. The things that have no effect on the time of your flight are the horizontal motion, which is going to be your horizontal velocity. When we have projectile motion, we treat our horizontal and our vertical components as independent systems. Our horizontal velocity is going to be constant if we ignore our air resistance, and it only is going to affect our range. Our vertical motion is going to be governed by our gravity, and that is going to be the only force that is going to cause the object to return to the ground. And because our vertical velocity and our horizontal velocity are orthogonal, they have no influence on each other, and we look at these two different vectors separately so that we are able to add our vertical motion and our horizontal motion. Now, if we analyze our kinematic equation, we have the vertical displacement y of a projectile launched from a height of h is given by vy initial t plus or minus, gt squared. Now, in order to find the height or find the flight time in total, which we'll call t here, we're going to set y equals 0 for the final height. And this is going to be our ground level. Now, this is going to make our 0 equal to our y. That'll be h, and then we'll have, instead of vy initial, we have this is equal to v initial sine of theta. And this will be multiplied by t. We'll subtract this by 1/2 gt squared. So because we have vx equals v initial cosine theta not appear in the vertical displacement equation, that means that whether an object is dropped vertically where your vx is equal to 0 or fired horizontally at 1,000 meters per second, making your vx equal to 1,000, if they start from the same height h with 0 initial vertical velocity, they are going to hit the ground at the same time. We can confirm this by looking at these two examples here. So we have a low vx, which is 5 meters per second, as our blue line, and we have a high vx, which is 12 meters per second, and we can see that they are both going to be launched from the same height. Now, we're going to see that at the times 0.5 seconds, t is equal to 1.0 seconds, and t is equal to 1.5 seconds, we're going to have the same amount of height for this entire motion, but the horizontal distance is the only thing that is going to vary with these different initial vx's. However, the time is still going to correspond on each of the curves. Therefore, it's still going to take the same amount of time for these two curves to launch, even given that the vx's are different.